Hello everyone, welcome to another tutorial on 3G 4G where we will try and look at what is meant by Open RAN, White Box RAN and Virtualized RAN or vRAN. This tutorial will include some practical examples and stories as seen by us. This may be different to your experience, so please feel free to share your experience, comments, stories below in the comment section. We have looked at this diagram in quite a few tutorials before. Simply put, we have two parts in a network, the core network and the access network. I'm sure here the transport network engineers are shouting that transport network is a very important aspect within a network, but for this particular tutorial we are going to stick with the core and access network. Note that here we are representing 2G, 3G and 4G networks to highlight the same concept that applies to all generations of technology, including 5G. Simply put, the core network contains hardware and software, and the access network contains hardware and software as well. So in the core network, you may require different kinds of functionalities that include firewall, routers, gateways, etc. Each vendor used to have a proprietary hardware and software for each of these functions. There used to be many such boxes in a network data center, consuming lots of space and power. They used to be difficult to upgrade and replace. With network functions virtualization, the purpose-built hardware got replaced by COTS or commercial off-the-shelf servers. This allowed the operators to get standardized hardware at a much lower cost due to economy of scale and the best quality to install in their data centers. So instead of having hardware specialists dedicated for each hardware kit, now there were generic hardware specialists. Different vendors can now focus on software rather than hardware, so their products became more flexible and streamlined. This picture is just a silly analogy to explain how the different gadgets we used to own has gone from hardware to software. So though this may not be completely applicable to our scenario, it just shows how NFV has enabled moving hardware into software. So let's look at access network now, which is going to be the main focus for this video. So you have seen this picture before in macro cells and small cells tutorial. If you haven't seen it, check it out. Now there is a link at the top. This picture just shows that in olden days we used to have cabinets that used to contain all the circuitry, hardware and software, and the antennas used to be connected via RF cabling on the top of the tower. So with high data rates of 3G and 4G, the access network model changed to having a BBU in the cabinet and the RRU up on the tower. The RRU is just the hardware, whereas BBU is hardware and software. In the contemporary RAN, RRU is a proprietary hardware. BBU is a proprietary hardware plus software. And the BBU is often connected to RRU with proprietary interfaces or signaling, even though it may use CPRI protocol. With virtualized RAN or vRAN, the proprietary hardware remains as it is, but the BBU get replaced by COT server rather than a proprietary hardware. The software that runs on BBU is virtualized to run on any COT server. The proprietary interfaces remain as they are. So the point to emphasize here is that vRAN is not Open RAN, as it's not completely open. It still contains proprietary interfaces and purpose-built hardware. So what exactly is Open RAN? The Telecom Infra Project Summit or TIP Summit by Facebook had some interesting presentations on this topic. The one by Vodafone and Telefonica is really relevant for our discussion on Open RAN topic, and we will show some slides from that particular presentation later. So this particular picture is showing how the traditional RAN vision has evolved to Open RAN, and even how the Open RAN vision is evolving further. The main point to note here is the disaggregation of hardware and software. So mapping the Open RAN vision onto the picture we have been using, the RRU or RRH becomes the hardware becomes the GPP based COTS hardware that can be purchased anywhere from any ODM, OEM or RAN hardware vendor. GPP means general purpose processor. We will look at it in the next slide. So just in case you may not know, ODM stands for Original Design Manufacturing and OEM refers to Original Equipment Manufacturing. So there is a lot of confusion about these terms. So let's say that let me try and explain this in simple terms. So Apple designs their own products, but when it comes to manufacturing, it will ask an ODM or original design manufacturing firm like Foxconn to manufacture it. On the other hand, when you see an operator branded phone, they are designed and manufactured by an OEM or an original equipment manufacturing company. The operator just takes it, puts their brand on it and sells it as their own phone. The BPU here remains the same as in case of vRAN. COTS server plus vendor's own proprietary software with virtualized function. But the main thing is the interface between BBU and RRU is now an open interface. So any vendor software can work on any open RRU or RRH. A quick explanation of difference between general purpose processor GPP and single purpose processor SPP. Sometimes I have seen for the S to represent special rather than single, so it becomes a special purpose processor. GPP is basically the CPU, and the most popular example is Intel's x86. It allows true hardware software disaggregation, and a generic architecture allows economy of scale, low cost and faster innovation. SPP, on the other hand, is designed for specific purpose. It requires a lot of R&D, costs are high, specialized experts are required, etc. It would, on the other hand, be a much better optimized architecture for the purpose it's designed and can be much more faster, consuming less power. Coming back to Open RAN, there are quite a few vendors who are designing all-in-one RAN solution. So instead of a separate BBU and RRU, it's all combined in one box. You can see the architecture in the picture used by Facebook's Open Cellular Group in Telecom Infra project. A white box RAN is an all-in-one GPP based base station that has BBU and RRU. There is still a need for software on it, the same way as what goes on BBU. Only the hardware is white box. The interfaces of this white box is standard 3GPP based for protocols and something like the TR069 for management. You can still have a white box RRU with a COTS BBU. So the important question here, will Open RAN work in practice or is it just another fad or theoretical concept? Vodafone, Telefonica and some other large operators are big supporters of Open RAN. Vodafone and Telefonica had issued a joint RFI or request for information that was sent to all the vendors working on Open RAN concept. At TIP Summit 2018, they announced the results. I'm going to use some slides from the presentation by Vodafone and Telefonica at TIP Summit 2018. So the main objective of RFI, as can be seen, was to align operators' requirements with that of vendors, assure them that the operators are seriously looking at this solution and there will be a lot of demand to come from these operators. Identify the Open RAN movement leaders and to foster competition and innovation. You can see from this particular slide that there are quite a few big and small vendors who actually participated in the RFI. There were three main evaluation criteria: openness to enable multi-vendor interoperability, performance, which looked at not only 4G but also 2G and 3G feature readiness and time to market, which looks at how many vendors have already invested in R&D effort and are ready today in comparison to vendors who will be ready in a few months or years time. It is important to emphasize here that 2G and 3G networks are not going away anytime soon. Some countries are switching off 2G and some are switching off 3G, but majority of the world will still have combination of 2G, 3G, 4G and even 5G networks. As this slide emphasizes, legacy is still the key for deployments. If I remember correctly, GSMA Mobile Economy Report in 2018 mentioned that 4% of the global population will still use 2G in 2025. Now you might think 4% is not a large number, but this still amounts to 360 million users in 2025. So here is the list of best performing vendors of the RFI for different categories. As you can see, parallel wireless is present in all categories apart from innovators and challengers, which seem to be dominated by newcomers. Before we start looking at the business case for Open RAN from an operator's viewpoint, I came across this interesting picture from Radisys. As it says, traditional RAN implies vendor lock-ins, high cost, proprietary interfaces, etc., as we already discussed. In case of Open RAN, open white box hardware can be used by any software vendor. Open interfaces allow innovation and easy disaggregation of hardware and software, and all the other points which we have already discussed. So what's motivating the operators to look at Open RAN? We have taken an example where the operator is using Open RAN white boxes from vendor A and has software from vendor V1. Now the operator is expanding the network. They may decide to introduce a new software vendor V2 who puts their software on the white box A. Now there is a healthy competition between V1 and V2. Suppose the hardware from white box vendor A is not performing well or these white boxes need upgrade. The vendor can get new white boxes from vendor B and C. As they are all Open RAN architecture, the software from